Hi class, in this video I will illustrate how to draw Lewis structures. All these examples are for species which contain multiple bonds. Recall the basic steps of drawing Lewis structures. The first step is to count the number of valence electrons. I've already done this. The next step is to choose the center atom. In the first example, carbon is the center atom. Carbon usually needs to make 4 bonds, and given the choice, if carbon is present, it will be the center atom. In the next example, carbon is also the center atom. In the next example, HCN, carbon is the center atom. In ozone, or O3, the only choice is oxygen to be the center atom. The next step is to draw in the surrounding atoms. The next step is to connect the center atom to the terminal atoms with a single bond. You also must subtract what you use from the number of valence electrons. The next step is to give terminal atoms a complete valence. In the first example, the hydrogens already have a complete valence. The oxygen needs 6 additional electrons around it. Then I subtract what I use. In carbon dioxide, each oxygen will need 6 additional electrons around them. In HCN, the nitrogen needs 6 additional electrons around it. In ozone, the terminal oxygens each need 6 electrons around them. The next step is to take any electrons that remain in the valence electron count and put them on a center atom. In the first example, no electrons remain. In the second example, no electrons remain. In the third example, no electrons remain. In the last example, ozone, O3, 2 electrons remain. At this point in each of the examples, we have used up all our valence electrons. However, if you look at the carbon in H2CO, the carbon does not have a complete valence. So in order to fix this, all we can do is steal electrons from a terminal atom and make a multiple bond. So we have to steal electrons from the oxygen. Now, the carbon has a complete valence. It has 4 bonds, and we've used up all our valence electrons. The oxygen still has a complete valence with 2 lone pair and 2 bonds, and both of the hydrogens have a complete valence. This structure is a valid structure. However, it is normal to redraw the structure. In carbon dioxide, we've used up all our valence electrons. However, the carbon only sees 4 in its valence. So we're going to steal lone pair to make multiple bonds from terminal oxygen. First, I'll steal from the left oxygen. The carbon still does not have a complete valence. It only sees 6 electrons around it. And we have a choice here. We could steal from the left oxygen or from the right oxygen. Due to symmetry and the fact that the 2 carbon to oxygen bonds should be indistinguishable, we're going to steal from the right oxygen. Now, the carbon has a complete valence, and each of the terminal oxygens have a complete valence. However, I'm going to redraw the structure. In the next example, HCN, the carbon does not have a complete valence. There are no lone pairs to steal from hydrogen, and hydrogen can only form 1 bond. Therefore, I'm going to steal them from the nitrogen. Carbon still does not have a complete valence. I'm going to steal another pair from the nitrogen. Now the carbon, the nitrogen, and the hydrogen all have a complete valence. I'm just going to redraw the structure. In the last example, ozone, the middle oxygen only sees 6 valence electrons around it. And I have a choice here. I can steal from the left or the right. However, those oxygen to oxygen bonds should be indistinguishable. So really, there is no one answer. This structure is what we refer to as resonance structures. So first I'm going to redraw it, stealing from the left, and redraw it, stealing from the right. The structures for ozone on the left or the right are not complete pictures. Really, there is only one molecular structure of ozone, and it is an average over both of the Lewis structures that I have drawn for ozone. So how do I indicate that? How do I indicate that the true structure is an average over both structures? You do so with an arrow. What we refer to this as a resonance structure. In resonance structures, it's an average over both structures. We wouldn't say that ozone contains one single bond and one double bond, and in fact, those oxygen to oxygen bonds on the left and the right are completely equivalent. It's more like ozone contains 1.5 bonds on each side. There's no way to draw 1.5 bonds. So we draw the two structures with an arrow separating them to indicate they are resonance structures. In the next video, I will illustrate more examples of drawing resonance structures.